Hello folks, this is the lab activity in lab number 10 for the morning session. It is taken from an old final exam and you are expected to generate this mechanism which involves two joints, a revolute joint and a prismatic joint, and introduce rules into it, which makes this mechanism follow the pattern of displacement and the angle that you see down here. All right. Got the trace of the point A as a function of time. Now, in the past, we had most of the traces that we had done, pretty much all of them, I think, were for a single degree of freedom system, and it didn't matter how fast that thing moved. But here, this rule is important. Depending on how fast these things move, depending on these rules, the trace will change. Now, and there are some differences on how you do it as opposed to what we had done before. Now, it is true that when it comes to making these things, it looks, I told you I'm going to replace this with a single cylinder, except that try to stick to the drawings that I have, because in case you can't finish the problem, at least you can collect some part marks for some of the stuff that you have done. Yeah, I have a product file here, which I'm going to immediately save it with a meaningful name. So file, save management, save as. Okay, so let me insert the base. Let me insert the the base first. So insert a new part in there, and I'm going to call this thing the base. Right click properties. Where is that? Properties, uh, base, and base. Okay, so you know what? I for a minute I thought that maybe I should replace this thing with a cylinder. No, I might as well do exactly like what I have here. Okay, so on that plane I will sketch a cylinder like this, or a circle like that. Exit, pad it. Yeah, okay, so I'll make it 0.5. On that face I will sketch two concentric circles. There we are. Exit, pad it. Okay, so this is going to be that yellow thing. Okay, now I'm going to do the arm. So let me do that like so. On that face I will sketch. Why don't I project that circle? There we are. And exit, pad it a little bit more, maybe 1. Okay. All right, now I'm going to change the color of these so that they look different. So let me change this thing to yellow, the base to yellow. Oh my God. So common mistake. I see, please look what I did. I made that other piece inside of the base. That was not intended. So this delete. It's so easy to make that kind of a mistake. So we go all the way to the top, insert, new part, say no, right click arm. You see how much time you waste if you do this? Arm. Okay, now let's do that. double click on this. On that plane, I will sketch exactly the same thing. Project that circle, exit, pad it by 1. There we are. Okay. Now it's not quite done. It doesn't look like that. So let me make it like that. Let's go back here. And there are many ways of doing this thing. That's entirely up to you. On that face, side face, I'm going to sketch. Okay. Rectangle. Something maybe like this. Exit. Pad it in both directions, but that's too much. Maybe 0.3. Let's see. Yeah, why not? That looks good. And then I want to take a little thing out of that so that it looks nicer, like what I have. So on that face, I will sketch. And you understand, once again, you understand why I'm asking you to try to give me something that looks like mine in case things don't work out. At least you can get part marks for putting some effort into making something that is at least looks like mine. So pocket, the other direction. Oops, no, that was correct. Let's drag. Okay, that'll do it. Okay, good. That looks something like what I have. Now we're going to go all the way to the top. Insert the slider. Insert, new part in there. Call it a slider. Right click properties. Slider. And slider. Okay. Say okay. And let's do it on this face. On this face, I will, let's actually go make it. Double click on that. I don't want to make the same mistake that I did a minute ago. On that face, I will sketch. Why don't I project actually uh, those edges? So let's see now. Project. Yeah, I can do this sketch, right? Okay, good. Exit. Pad it. Let's go. Yeah. I don't know how long these things are. First of all, let me change the color on that. It just makes it look nicer. Hang in there. Cancel. This. Right click properties. Let me give it a different color. Maybe this. Okay. I just want to have an idea how big these things are. So let me measure that. This is now remember our slider is going to go out 5 inches. So this is 2.94. You know what? Just so that it looks more realistic with the drawing that I have, I go make this thing longer. So that was arm, right? It was this pad. I believe it was this pad in the arm. This pad. It was this guy. Oh no. It was the sketch. Yep. Make this thing a little bit longer. Okay. Oh, you know what? Hang in there. That one is okay. It's this pocket this pocket. That's fine. No problem there. I also have to clean up this pocket. Yep. Okay. That's good. And I'm pretty sure this is fine. So I'll go all the way to the top. All the way to the top. You can make this thing go all the way to the end. It really doesn't matter because it doesn't affect the mechanism. All right. So we go all the way to the top. Let me drag this thing a little bit to the right so that you can see that it can stick out of that. Good. Now we're going to assemble. So anchor the base there. This is going to be a revolute and this is going to be a prismatic. I suggest you also check the morning sessions homework, because that is a different problem and you get to do two problems basically. So coincidence between the axis of this and the axis of that, and coincidence between this plane and the plane at the bottom. Oh, actually, cancel that. I want to show you why. Let me bring this thing to the front. So we want a coincidence because I went from here all the way to the bottom here. Okay, so I want to use that plane, this plane, and let me hide that one. The other one would have worked too, but it would have given you a revolute joint with an offset, which is fine. There's nothing wrong. It would have worked. So that's going to be a revolute joint. Okay, now let's make a prismatic. So, for example, coincidence between this and that. You know what? Cancel that for a second. We just noticed something, and that is, oh yeah, that was an illusion. Yeah, that's good. That was an illusion. Okay, so coincidence between this plane and that plane, and coincidence between, for example, this. Let me see for cancel. This last one, I'm not sure whether I did it right. Let's go to the last one for a second. Yeah, delete it. Okay. Coincidence between, for example, because these heights are different, you've got to be careful. Coincidence between this plane and that plane, for sure, that's okay. And coincidence between this edge and, let me hide that edge. Okay. Let's bring it into the show mode. All right, I'm pretty sure this is okay. So save, floppy. Now we're going to go to digital markup, DMU Kinematics, get the magic wand out, new mechanism, auto create. There should be two joints, a revolute one and a prismatic one. If not, then better find out what we did wrong, what I did wrong. Yeah, revolute and prismatic. Good. Now let me double click on this, make this thing angle driven, and double click on that, make this thing length driven. Okay, obviously mechanism can be simulated, I know that, and I can always try it, but I'm not going to. Now, we have to put these rules into our problem, okay? And remember how we do that, we go to, one way, the way I showed you is this. You go to start, and you go to knowledgeware, an extremely important toolbar or application, let's put it that way, a knowledge advisor, and this will allow you to write programs, okay, right there. So you click on it. The first one, I'm going to do the translation. So translation, slider. How about saying slider? Slider, which is the translating part. And then we can start typing. Now, in the class, I mentioned that because these breakpoints are different, this is at 6 and this is at 8 and this is at 5 and this is at 9, it's wiser to write it as two rules, one for the slider, one for the arm. If these were at the same location, the breaks, then probably one rule would be okay. It'll be faster. But here, because these are breakpoint, it's more efficient to do it as two rules. That's why I broke this down into slider, and then I'll be doing one for the arm. So it says if now, if you want to see the only filter out according to the stuff for your mechanism, just click on the mechanism. It just filters it out. Okay. So if time is less than, I believe that is 6 seconds, right? 6 seconds. 6, don't forget the S. And then you say the length is equal to, double click on it, puts it there, equal to, what is that speed? It is 5 inches over 6 seconds. 5 inches over 6 seconds. Look, 5 inches over 6 seconds. So I'm going to say 5 IN divided by 6S, okay, times time. Here's the variable time. All you have to do is left double click on it, it puts it up there. Else, if, and if you forget the keyword, just click on the keywords, it tells you what it is. Else if, okay, else if the time is less than, the breakpoint is 8 inches, 8 seconds. 8 seconds. What I mean by the breakpoint is this, okay, is equal to, the length is equal to, notice that the length at the end of 6 seconds is at 5 inches, and then it begins to decrease. So I'm going to make it minus, and it's going to be 5 inches over 2 seconds, right? So you can see that 5 inches over 2 seconds, it drops down to 0 basically. So 5 IN divided by 2S, close the parentheses, times, open the parentheses, time, do not forget the shift, 6S, minus 6S, okay? And then else, which means after 8, see that the break was 8 here, after 8, so else, enter, length equal to, it is sitting at 0 inches, okay, and then plus, again it increases, and by how much? It goes to 4 inches over 2 seconds. 4 inches over 2 seconds, 4 inches divided by 2s times, open the parenthesis, time, and the break point was what is that? Was 8, right? We should always go and check this. We will. 8 seconds. Okay, let's check a few things. First of all, if time is 6, that should be at 5. So time is 6, that should be at 5. Either you put it here, you get 5, or you put it here, you get 5. Because 6 minus 6 is 0. Multiply by that, you get 5. If the time is 8, it should be 0. Time is 8, either you put it here, you put 8 there, you will get 0, believe me, try it. Or you put it here, and you will get 0 because 8 minus 8 is 0. Very good. Good. If there are any syntax error, it's going to pop up here. We say, okay, no syntax error. Notice that a law has been created. Slider. Let's do another one. And this one, I'm going to call it arm. Arm. Say, okay. Okay, so now we're going to follow this curve. So 5 seconds is the break point, and it's 90 degrees. So let's see now. If kin time, here, click on the mechanism so it filters it out. Angle, if kin time is less than 5 seconds, angle equal to what is that slide? What is that slope? 90 degrees in 5 seconds, right? Let's check it out. 90 degrees. 90 degrees in 5 seconds. Very good. Times parentheses time. I don't need the parentheses. Time will do it. Okay. Else, if time is less than, now let's see what the breakpoint is there. 9 seconds, right there. You can see that 9 seconds. 9s. Angle equal to, it starts at 90, DEG. Don't forget the DEG, and it then increases by 270 degrees over 4 seconds. Yeah. So plus 270 degrees divided by 4 seconds times parentheses time, and don't forget parentheses time, and the breakpoint is 5, right? 5 seconds. We should always check. 5s. I'm going to check this. For example, notice that when the time is 9, 9 minus 5 is 4. 4 that cancels this 4 in the denominator here. 90 plus 270, and that's 360. And that is correct. At 9 seconds, 360. And then it drops. So it drops to else angle equal to 360 DEG minus 360 degrees in 1 second. 1 second times time, don't forget the breakpoint, minus 9s. And check it out. When the time is 10, 10 minus 9 is 1. 360 minus 360 is 0. And that's precisely where it's supposed to be, 0. This is the angle, right? And once again, it's very easy to make syntax mistakes here. So, but I don't think I made any. There we are. Okay, good. So first of all, let's check. Let's save everything before I regret it. And then we go back to mechanism. Okay, we are in mechanism. Here are laws. Why don't we create a, first of all, let's create a simulation with laws. Make sure that we recover these two curves. If you don't recover these two curves, we made a mistake somewhere in the programming because there was no syntax error here. So how do we do that? So let's check, first of all, let's do a sensor here. So where's the sensor? Ball rolling down the hall, down the ramp. Reference product is the base. The point to look at is this point. Okay, good. Now, simulation with laws. Activate sensor. Now, all I want to know is the motion of these two commands. So all I need actually is the first two. These first two will not give you information about that point, but it will give you what are the commands that I actually using those rules. So you say play. Oh, the prismatic one is the wrong direction. Rewind. Close. Go back to the prismatic one. Prismatic. In the joints. Prismatic. Let me double click on it. Let me close that. Prismatic. There. You see that? The arrow. See this? Flip it. Flip it so it goes in the other direction. Very good. Let's go back to simulation with laws. Activate sensor. Those two that I checked are already there. And play it. It goes to the right. Okay, very good. It goes too far to the right, but that's okay. So I could have made this thing longer, etc. Rewind. Oh, no, not rewind. Graph. These better be those. Otherwise, the rest of the stuff that I'm doing is nonsense. And it is. I don't like it that this is not far enough, but that's okay. That's okay. So rewind, close. So let's see what else that we want here. It says, plot the magnitude of the linear of the linear. It doesn't say the magnitude, but if it doesn't say, it doesn't give component either, it must be the magnitude. So magnitude of linear velocity, which is linear speed, by the way, against time. Okay, so let's go here. And later on, by the way, it's asking about the magnitude of linear velocity against the magnitude of linear acceleration. Okay, so that being the case, let's go back here. Go back to simulation with laws, activate sensor. Now, first of all, I don't need the first two because I already verified it. What I need is the linear speed. I need the linear speed and linear acceleration. These two. This is magnitude of linear speed. This is magnitude of linear acceleration. And we move this thing out of the way. Okay. And we play it. Okay. Now, graphics. Now notice that it gives me two graphs. Okay. If it's confusing you, here's what I suggest. Close this, rewind, clear the history. Don't ask for acceleration to begin with. If it's confusing you, otherwise just leave it alone. It's just linear speed right there. Okay. Play. Good. Graph. A single curve. Make sure you zoom out so that I can check your units, make sure it's okay. Now you do a print screen, and then you go to a Word document, and you paste it, and you save it. File, save as, browse, desktop, afternoon, right? Homework 8 afternoon. Let's check it out. I'll call it linear speed versus time. And it's going to go in that folder. Close that. Close this. Now, the other part, it says linear velocity or linear speed against the linear acceleration. Now remember, I did not ask for linear acceleration. In fact, I asked that, then I went and unchecked it so that you don't get confused. Linear acceleration, rewind, clear the history, and play. Okay, so the plot that we want is not versus time. If I say graphics, it'll give me exactly what I had originally, two graphs as a function of time. That's not what I want. So I go to options, customize plot, add, it says, what do you want? Well, linear speed, and on the other axis, linear acceleration. It's there. And I say, okay. So curve one has been created. I close it, and I say options, and there we are. This is linear, this is linear acceleration, and this is linear speed. Okay, that is the graph. Complicated, isn't it? Yes, yes. So once again, print screen. What is that? You go to Word document, paste it, save it, file, save as. That folder afternoon, it was right here. No, not new folder. I don't want a new folder. Let me go browse. Let me go browse. Desktop. Homework 8 afternoon, right? Homework 8 afternoon. Where is it? Right there. And I call this thing linear speed versus linear acceleration. It's always to go back and check, make sure these are actually saved here, because you don't want to lose the opportunity and find out that, oh, I forgot. Let's check, minimize this, minimize that. Homework 8 afternoon, homework 8 afternoon. Yep, these are all saved and these are all saved. I can check it, for example, right there. This is the first one, yeah, versus time. Good, good. So we go here. We're done with this. So rewind, close. Okay. Now the only thing that I haven't done here is this one. Take okay. So magnitude of the wait a minute. Now where's the trace? Oh, generate the trace. Now, as I said, the situation with the trace is different from what we had done in the last 3 weeks, because there it was a single degree of freedom. It doesn't matter how fast these things move. So here it is different. Please pay attention to this. Before, if I clicked on trace, it will come back and say, hey, you need to have a replay. But here, if I click on the trace, you see that I can select the mechanism. Element to trace out is this point, and reference product is that base, no problem. And we say, okay, watch what happens. Whoa, whoa, complicated. So save this thing, file, save management. This is the trace, save as, in that same folder, not the morning one, afternoon. Where's the afternoon? Afternoon. There we are. We say okay. So now I can close this if I wanted to. I can bring it in. So insert existing component in there. This morning, no, not morning, afternoon. Trace 4. There we are. Look, ooh. So you can see what happens as this thing, you can check it out. Oh, not that one. You can check it out as you, okay, let's do it a little differently. So we go to maybe 3 seconds, see where it is. There, you can see that. We go to 6 seconds, find out where it is. Oh, not there. 6 seconds, play this right there. You can see that. It's kind of unfortunate that I did not make this thing long enough, but that's okay. So that's pretty much it. Save it. So remember, for the trace, this is not how we were doing it previously, because previously it was single degree of freedom. Trace did not depend on how fast these things move. We had to create a simulation, compile it, etc. Here, we don't have to. Just click on the trace. It says mechanism. Okay, select the mechanism. And that's pretty much it. Good luck.